given for a given electric field and magnetic field, we need to prove that the amplitude of the electric field as we know it is c, speed of light, times the amplitude of the magnetic field, which makes sense. It's a lot larger than the amplitude of the magnetic field. So given those two fields, we need to prove this. Yeah. Ideas how to proceed here, Ben? It's actually straightforward. We just differentiate the electric field with respect to x. We differentiate the magnetic field with respect to t, partial derivatives, of course. We take negative that equated to the partial derivative of E with respect to x, and then we see what condition that imposes on the amplitudes. And if everything is done correctly, that condition should be the result. The fact that the magnitude of the electric field is c times the amplitude of the magnetic field.
So I guess
let's see. Well, if what's dE over dx? Let's find out. So dE over dx, partial derivative of the electric field with respect to x will be the amplitude E0. Yeah. Times cosine is minus sine. Kx minus wt, and then if we differentiate chain rule inside the cosine with respect to x, we get k.
Yeah.
So this gets us negative k E0 sine kx minus omega t.
Yeah, that's what I got.
Okay, and then let's see what dB over dt is, or minus dB over dt. So we have minus dB over dt, so we will differentiate this with respect to b, so that's b0 amplitude. Cosine is minus sine, yeah, so then minus sine kx minus omega t, and the partial derivative of this with respect to t, so chain rule inside the cosine, you get minus omega. And so you have three minuses, so that's a plus, minus, I mean.
Yeah.
So minus omega b0 sine kx minus omega t. So for these to be equal, these two to be equal, if we set them equal, we will get I could cross out the minus signs, so k E0 sine kx minus omega t has to equal wb0 sine kx minus omega t. Okay, well, we could cross these out and we can get k E0 equals wb0. Okay, so then E0 has to equal w over k b0. Think about it. What's w over k? That's the speed of the wave.
Yeah.
And yeah, the electromagnetic wave goes at the speed of light, so this is c.
Oh yeah.
b0. So yeah, so they will be equal provided that the amplitude of the magnetic field is 1 over the speed of light, the amplitude of the electric field. And even if you didn't know, you could tell this from the units. Omega is in radians over seconds, and k 2 pi over lambda, that's the wave number for the wave, that's radians over meters. And so if you divide these two, you get meters over seconds, which is the speed of the wave. So you do have to divide the angular frequency by the wave number to get the velocity of the wave. Questions on that?